Okay. Today we will talk about what kind of reactions are provided to keep any particular body under equilibrium. Whether that particular, by providing the reactions, system is uh, whether the system remains under static equilibrium or not. First of all, that is the point. You also have to find out whether the system is statically, that the number of unknowns that are adding up because of the support should be able to compute those unknowns by using the equilibrium equations. And the third thing is whether your system is like fully constrained or partially constrained, or like improperly constrained systems. Okay. So we will first talk about the type of reactions, or let's say support. So in two-dimensional case, you will see that a body which is supported by, so here if you try to see this one, or you can take some particular kind of roller, right? And this can also be, let's say this is your frictionless. Draw the free body diagram of all this, you will see that here we will have just one component, right? R1. Here you will be having again component, which is R1. Here again we will be having component, which is R1. It means that this kind of support, gives you number of unknowns, unknowns just one. Okay. Similarly, if you try to plot second kind of unknowns, for example, that this position is fixed, here if you draw the free body diagram, then you will have x component, let's say rx, and ry component. So loans are adding up because of this. Again, you can take another case where your like here this particular thing is rest on, you know, so if you draw the FBD of this particular body, what will happen? You will be having one. So it means that because of this Rx, uh, this is how you will be standard Rx right? And this is your Rx. Okay. So here again it is adding two unknowns. Eventually, this kind of supports, or this kind of support gives you two kinds. And if you try to see the kind of support in which completely fix your means that like this. So if you try to draw the ability of this particular system, one is your Ry, Rx, and you will see that there is also another component which is point A, this will be. There are three unknowns which are Rx, Ry, and unknown. Number of unknowns added by support, number of unknown added by this support. Okay, so it and eventually you can also have like, let's say this is your fix here. So the ability of this particular body, let's say theta. How you try to find out the type of reactions them to support addition. Now, so this is a 2D case. So how many, like what will be the equilibrium expression? See that equilibrium equations when you write, they are basically summation of fx is equal to 0, summation of fy equals to 0, and summation of m equals to 0. Equilibrium. And ultimately, requires that you should be having the minimum of maximum of three unknowns can be solved by equation. For a given system, if all the forces are satisfying this particular condition, then all such kind of equations that system as equilibrium. Now let's go to. So let's say if you'll have to replace three unknowns. In that case, hold some point. One roller and then I can also have one rope, one cable kind of support, and one pin. So again, this will give you or I can have one that also gives. So basically, a system can be supported by a combination of different. So if this kind of condition, all such kind of condition to be statically determinate system. So it means that now let's try to write down. So if there are three unknowns, if there are three, all the equations for example, now the question is that what will really happen? One can ask the question, what will really there are one what it is going to give you number of unknowns. So what will really happen? So let's try to call indeterminacy condition statically. So in the first case, let's assume that the number of unknowns are greater than number of equations. So thing is, it may be proper, a proper thing, but point remains here. Proper thing, thing condition. However, comes statically indeterminate because the number of unknowns are more, number of equations are less, so you will not be really. And second point that you may be having is the equilibrium depends on depends on whether it satisfies all these conditions or not. Now, second case. So basically, this will more or less. So this there is a doubt whether it is a proper constraint condition or not. There is also doubt whether it is doubtful. Need to check. However, what is certain that this point, this particular point gives you that is statically indeterminate. Statically indeterminate. Indeterminate system. Okay. Now what will happen if number of unknowns less than So in this case, we can say that system will be system is statically or indeterminate based on whether the proper forcing allowed or not. Okay. Most of the time you will see that the system will be static. So this is what will be your, otherwise you will have to see whether the proper conditioning is required or not. If the proper conditioning is not required, you can see whether it is a determinant or indeterminate. Second question that is required is partially constraint. Okay, partially constraint. And one checked. Okay, so doubtful thing are, however, what is certain is it is partially. Okay, now in this case, when number of unknowns same as number of equations. Okay, so if the reactions are parallel or concentric, parallel or concentric, in that particular, this is very important statement, parallel or concentric, then your system will become improper constraint. And in that case, statically determinate system and equilibrium needs need to be checked. So this is how you try to, let me again, explain these things. From here we found that the system will be equilibrium if you have three unknowns coming out from the support system. You can select different kinds of system. Now how you are providing the support? Three unknowns are there, but how you are putting it? Now the way you are going to put also define whether the constraints are proper or improper or partially proper. Okay? So when the number of unknowns are greater than number of equations, that like there are the proper constraints may be proper because it is providing complete constraint of your degrees of freedom and down your number is already satisfied, but you will have to see whether it is proper or not. So that has to be checked later on. But what is certain out of this condition is that first number of unknowns. Second point, and for equilibrium again you will have to satisfy. If the number of unknowns less than number of equation, it means that your system is partially constrained system. That number of equations are more and unknowns are less, there will be some degree of freedom. Can't really, satisfy that. So again, the two things which are doubtful are statically determinate and when you are having improper, like when unknowns are same as this, it means that you are almost satisfying the condition of this requirement where three unknowns are required. So it may be statically determinate or indeterminate. Maybe and provided the equilibrium equations are satisfied, then it will be statically determinate. But if those unknowns are provided, if those reactions are provided such that they are parallel or concentric a point, then they are called improper constraint systems. For example, example 1. So let's say you have a system over there. Here you are here you are providing another. So first of all, if you draw the ability of this particular point, and this is B, R, A, X, right? R, B, Y, and direction R, B, X, right? So first of all, you will see the number of unknowns over here are 1, 2, and number of equations that you number of equations are 3. That means that it is satisfying the condition. Now, what you will have to really check for whether they are statically determinate. Find that system is statically determined. Now, whether the system is under equilibrium. So, first of all, you will write your fx is equal to 0. So, and let's say this is your w. So, if you write fx is equal to 0, what you will Rax Rbx equals to 0. Y equals to 0 will be Rby equals to 0. And summation of m about b will give you a is equal to minus R A X equals to 0. So it means that R A X that you are getting times W by 2. And what will be RBX? Right? So it means that you are providing a support like this. RAX is nothing but minus, and here So this is what you that the direction of this will get right. So important here is now you are able to compute all RAS and RBS. It means that the system all the three unknowns you are finding out from these equations. At the same time, all these unknowns that you have found are satisfying this particular condition. Equilibrium. Equilibrium. It is in equilibrium. Okay. Now what we have to really check is whether it is fully conserved or not. So you will see that all these reactions are RAX, RBX, and R and non-parallel, hence they are fully properly they are providing proper constraint system. Now let's look at one more example. Example number 2. Let's say the same system we are going to provide like now if you draw this is your W. If you draw the condition over here, A, this is your C, A, C. So this will be RAX, this will be RAY, this is your A, this is your A by 2. Now this is where you are getting your W, A by 2. This is your now when you write your so first of all, how many unknowns are there? Number of unknowns are equals to 4. That number of unknowns are 4. That this is greater than number of equation. So straight away you can say that this is statically statically in little. Second point that you can say whether they are in equilibrium or not. So if you try to if all these reactions are going to satisfy you, Fx is equal to 0, Fy equals to 0, and summation of m equals to 0. Okay, so let us say you can take it as A. So summation of Fx will give you R Ax is equal to RCx, right? Summation of this one will give you RAy plus RCy is equal to W, and summation a moment about this particular M of A is equals to M of A is equals to RCy into A RCy. This is nothing but this is known. Now you will know RAy, right? It will be W minus W by Now, what you don't know is this particular point. This will remain statically indeterminate. However, to get the equilibrium condition, require that this RAX is equals to condition. You may have your equilibrium condition satisfied. Are satisfied. However, some in later. And second point that you will notice here is all the constants are proper. So here all the forces are non-parallel and concentric. Proper P or constraint. Alright. And final example that I would like to give over here. Let's say what will happen if you provide this particular support. This here we are providing one support which is this. So first of all, reactions are here you are having RCX, here you are having RA, RBY, RBX. All the forces are so first of all you will get this implies that improper condition is there. Number of unknowns are I equal to number of which is 3, right? You have to see if you will be able to find all of them. So summation of factors will give you RCX and RBX, right? Now summation of FY will give you summation of FY will give you RBY. So RBY is known. Now if you take moment about B, so what will happen? W, but not be any reaction force which will not this one. W is minus W by 2 minus WA by 2. Not okay. So this system is improperly constrained. It is not in equilibrium, and also one unknown remains. So statically indeterminate system. Then if you are having three unknowns, system is not under control. So this discussion on reactions or support and equilibrium.